The rescue of victims from confined spaces is a dangerous operation. The hazards often include asphyxiation, flammable, toxic, and explosive atmospheres, and mechanical hazards, including tight restrictions within the space. These are dangers both to the victims and to the rescuers. A sad but true statistic is that 6 out of every 10 people killed as a result of confined space accidents are untrained rescuers, not the workers who first went in. In this program, Confined Space Rescue, we'll not only show you how to safely rescue a victim, but also tell you how to prevent becoming a victim yourself. First, we'll define a confined space. Next, we'll discuss the Permit-Required Confined Spaces for General Industry (OSHA) standard. Then, we'll discuss rescuer safety. We'll talk about personal protective gear and devices. And finally, we'll explain how to follow a rescue action plan in confined space rescue situations. Let's begin by defining what a confined space is. According to the Occupational Safety and Health Administration, a confined space must meet these 3 requirements. First, it must be large enough and configured in such a way that an employee can bodily enter and perform assigned work. Second, it has a limited or restricted means for entry and exit. And third, it is not designed for continuous employee occupancy. Confined spaces include tanks, storage bins, pits, and trenches, but the space is not nearly as important as the contents or the atmospheric conditions. Another danger is falls, which occur when people are entering or exiting the space. To address these 2 dangers, OSHA published a standard in January of 1993. It's called the Permit-Required Confined Spaces for General Industry standard. This rule states that a permit-required confined space is any area that meets the requirements of the OSHA definition of a confined space, plus the following 4 requirements. First, it contains or has the potential to contain a hazardous atmosphere. Second, it contains a material that has the potential for engulfing an entrant. Third, it is configured in a way that an entrant could be trapped or asphyxiated by inwardly converging walls or a floor that slope downward and tapers to a small cross-section. And fourth, it contains any other recognized serious safety or health hazard. Even though the standard was written for the general industry, OSHA has included a section for the rescue and emergency services. They have established minimum training requirements for rescue team members. The OSHA requirements clearly define what the training requirements are and what retrieval systems you should use in confined space rescue operations. The standard also includes hazardous materials information the operator of the confined space should provide to the medical facility. And the standard states that the person responsible for the confined space must provide you with access to the permit-required spaces. This will give you the opportunity to develop rescue plans and practice simulated rescue operations in those areas. So far in our program, we've defined what a confined space is according to OSHA and discussed the permit-required confined spaces for general industry OSHA standard. Now let's turn our attention to one of the areas of rescue that's always foremost in our minds: safety. During confined space rescues, your personal safety is particularly important. There are many hazards in confined spaces. Some of these are hazardous atmospheres, risk of falls, mechanical hazards, and dangers of flooding or engulfment. Some of the safety gear we'll cover include personal protective gear, atmospheric monitors, ventilation blowers, fall protection, communications, and lockout-tagout systems. Let's begin with your personal safety gear. The type of gear you choose will depend on the type of hazards present. For example, if you have to enter a flammable atmosphere, you'll need your fire protective gear. But if there's a storm sewer full of water, a dive rescue team trained in confined space operations will be needed. Hazardous material specialists wearing protective suits may be needed if toxic atmospheres are present. For most confined space rescues you'll perform, you'll need at minimum the following personal safety equipment: head, eye, hand, and foot protection, proper clothing for the atmosphere you're entering, approved breathing apparatus, a personal alarm locator, safety and retrieval lines, and a means for communication with other team members. Check your equipment every day and visually inspect it before each use. In addition to your own personal safety equipment, the entry team will need an atmospheric monitor. It detects high and low oxygen levels, upper and lower flammable limits, and explosive ranges in the confined space. Many detectors can test for toxic gases as well as oxygen and explosive limits. A common problem in confined spaces is sewer gases. These include carbon monoxide from passing vehicles, methane from decaying organic matter, and hydrogen sulfide, which comes from decaying concrete. As concrete decays, it oxidizes, both reducing oxygen in the space and creating this toxic gas. Although these gases are the most common, others can be present depending on the operation in the confined space. Check the monitors every day for proper operation, and check the battery and normal valves in a clean atmosphere. You can find proper checkout and calibration instructions in the manual included with the monitor. Electronic monitors are sensitive instruments. Calibrate them according to the manufacturer's specifications. They can break or go out of calibration. It's a good idea to have two on hand in the event one fails. Another important piece of equipment is your breathing apparatus. The one you use will depend on the type of atmosphere and the space limitations of the area you're entering. Most often, the self-contained breathing apparatus you use for building fires will be appropriate. Be sure it's in good working order according to the manufacturer's instructions. Don't rely on filter-type masks, since they can't protect you from low oxygen conditions. If you have to enter a space too small for a donned air pack, don't plan to have someone pass a normal air pack to you after you crawl into the space. Even with the mask on, you could fall, pull away from the mask, and lose your respiratory protection. If your breathing apparatus uses a low-pressure tube to supply air to the mask, be careful not to pinch the tube while squeezing through the space. A supplied air breathing apparatus is most often the best type of respiratory protection for confined spaces. This system uses remote air bottles to supply the mask through air lines. Small escape bottles capable of supplying at least 5 minutes of air are used in the event of a failure of the supplied air system. These small bottles make it easy to fit through tight spaces. Remember, these bottles are used for escape only and not as your only air supply. If you experience a malfunction that requires the use of the escape bottles, leave the area immediately. Use a blower to attempt to reduce the amount of dangerous gases before you enter. A blower can provide fresh air to the patient, but don't depend on it as the only source of breathing air. It may not clear the atmosphere adequately. Use your atmospheric monitor to confirm that the air is safe to breathe and keep it with you, constantly monitoring the conditions within the confined space. During a confined space rescue, a fall is always possible. Be sure your entry equipment has built-in fall protection. A good way to provide fall protection and access to vertical shafts is to use a commercially designed tripod. The tripod should be engineered to support the weight of two people, their gear, and provide an extra margin of load capacity for safety. Most commercially available tripods are rated for these types of rescue operation. A good tripod will have a way to anchor and stabilize the legs. It should have two separate anchor points at the top to attach a mechanical advantage system. And many tripods have man-rated fall protection devices built in. They also have a cable winch to hoist the rescuer and patient vertically. Since confined spaces can be very noisy and even echo, you can't rely on a simple shouting method for communications. Due to the design of the space, normal radio transmissions may be limited. Hardline communication systems are available, but you have to contend with an extra line. So it's important to work out a method of communications that will work in a variety of situations. It's also important to have a backup method of communications. Before you can enter a confined space, turn off all mechanical operating systems. Secure them with a lockout-tagout system, or station a person at the switch or valves to prevent turn-on. A lockout-tagout system accounts for shutdown mechanical systems. A color-coded lock for each person who enters the space is placed on a single lockout hasp at each disconnect. Check to see if one is in place and add your own locks to the system before a rescuer enters. Use similar devices to lock valves in a closed position. Electrical plugs, breakers, and switches also have special lockout devices available. So far in our program, we've defined what a confined space is. We've discussed the elements of the permit-required confined spaces for general industry standard, and we've presented some important safety equipment and devices used in confined space rescues. Now let's turn to the Rescue Action Plan. The Rescue Action Plan will help you get through rescue situations in a well-thought-out and safe manner. Let's quickly review the stages of the plan. They are preparation and response, arrival and identification of the hazard, size up, stabilization of the scene, accessing the patient, performing the rescue, securing the scene, and preparing for the next alarm. The first element of the Rescue Action Plan is preparation and response. Be sure and train for the types of rescue you'll be entering. Also, check your equipment daily for deficient items that need to be repaired. While responding, begin a mental size-up of the rescue you're en route to. Think about the type of space you'll be entering and the possible hazards present. Consider the use of the space and how it will affect the rescue efforts. Notice the weather conditions. Will rain be a problem? Most alarm centers have direct access to the Weather Bureau. They can provide updated weather information while you're en route to the scene. The next step in the action plan is arrival and setup. Begin a physical size-up of the situation when you arrive. Look over the area. Don't park too close to any ground-level opening or where exhaust fumes from the apparatus can cause a problem. Give an arrival report over the radio. Include a brief description of the scene. Then formally establish command. If the confined space is within a large complex, your arrival report may simply state that you are on the scene and investigating the situation. Your next step is to locate the actual confined space. Look for site representatives for specific technical support. Split the rescue team into a safety crew and an entry crew during the arrival phase. A size-up can be conducted by the safety crew, while the entry crew prepares the proper equipment for the rescue. Establish a tool staging area once the safety zone is determined. The safety crew should talk to any bystanders. If the area is a permit-required confined space, signs should identify it. An attendant should also be on hand to provide you with valuable information. Look for a confined space entry permit tagged to the space. It will have very important information concerning atmospheric conditions and special hazards. Put on your protective equipment before you approach the opening. Toxic fumes may be emitted from the hole. Check all equipment around the area and make sure all safety equipment is working properly. Lock out all electrical sources. Then add your own lockout-tagout system. If a mechanical problem is the reason the victim is trapped or injured, bring everything to a zero mechanical state. This means shut down the power source and block off any lines or hoses that present the danger. Crib when necessary to prevent machinery from moving. Isolate any hazardous material, high pressure or high temperature piping, or other piping that could introduce a hazard to the area. You may have to disconnect the pipes or double block them. A representative from the company responsible for the site can help you identify and stabilize any mechanical hazards. An extremely complex rescue situation is one that involves a storm sewer. It is nearly impossible to completely isolate the space because of the large opening and confined space area. The area can immediately flood from rain, fire suppression activities, or industrial releases of water or process waste. Hazardous materials can enter the system from industrial or transportation accidents. And the air can become toxic, flammable, or explosive from outside sources at any time. So, put on your safety equipment before you approach the confined space. Monitor the area for air quality and explosive or flammable atmospheres before you open the lid. The fumes can be lighter and heavier than air and can suspend at any level in the confined space. Then, use a probe to check all the way to the bottom if possible. Never rely on your sense of smell to do this. Many toxic gases are odorless, and you can't determine the oxygen content of an atmosphere that way. Obtain any material safety data sheets from the property representative for any hazardous materials used in the area. If a hazardous material is suspected, call for a trained hazardous materials team to assist. Use a ventilation fan to force fresh air into the confined space area if there's a hazardous atmosphere such as low oxygen conditions. Don't try to evacuate the dangerous gases by pulling air from the hole. There's a good chance you won't be able to draw all of the gases out of the space. And don't force pure oxygen into the space. It could raise the oxygen level to above safe levels. This can create a dangerous fire or explosion hazard. You can blow fresh air to the patient during the setup stage. This may give him extra time for survival, but don't rely on it as your only source of breathing air. Use protective breathing apparatus. The next stage of the rescue action plan is patient access. This may involve many different techniques. For example, when you enter an underground pumping station, all you have to do is open the lid at ground level. As the team prepares to enter the confined space, EMS personnel should stage their equipment to receive the patient. A secondary rescue team should be standing by in case something goes wrong. They'll work as part of the safety team. You may have to climb ladders or cross above-ground walkways to get to the confined space. Use running fall protection. You can create such a system with webbing, carabiners, and lifeline. Make sure all the components meet NFPA guidelines. In providing running fall protection for vertical access ladders, use a lifeline of half-inch dynamic kern metal rope. This rope should meet NFPA guidelines for dynamic lifeline use. The dynamic rope absorbs some of the shock if you fall. Wrap the rope around the bottom rung of the ladder with one round turn in the rope. This will work as a friction brake if you should fall. Connect the rope to your safety harness with a figure-8 follow-through knot, passing through the anchor point and the belt for added safety. Now, place a prusik or loop of webbing around the ladder rail just above the rung you can easily reach. Secure it in place with a girth hitch. Lock a carabiner through the loop, secure more loops around the ladder rail, and lock your safety line in as you go. A rule of thumb is to never let the lowest tie-off point be below your knees. This will keep the distance you fall to a minimum and reduce the shock load on the system. A rescuer mans the rope below, remaining prepared to stop the falling rescuer. If you have to cross a long horizontal walkway, simply clip in as you go. Fasten a loop about every 3 feet to prevent a long fall. To access a patient in a vertical shaft, you may have to use a built-in ladder or a mechanical advantage system to lower the rescuer. If you choose to go down the ladder, be sure to use fall protection and remain on the retrieval system while in the space. You can use a built-in hoist or a mechanical advantage system that has a rope lock in place. But the mechanical advantage system gives you more versatility. A good way to provide an anchor point for either type of fall protection device is to use a tripod or 2 ladders set up in an A-frame configuration. You can rig the fall protection device or mechanical advantage system with a locking device to the independent support above the hole. If the area permits, you can use a fire department aerial truck to provide the anchor over the opening. But don't use the ladder as a crane to hoist the rescuers and patient out of the confined space. You don't have as much control as the load is lifted. This is because as the ladder is raised, the load moves in an arc instead of straight up and out of the hole. The patient or rescuer could be banged into the sides of the hole. Use a 4-point harness to maintain a vertical posture when you go down the hole. A typical ladder belt or Class 3 harness can cause you to wedge sideways if you fall. Sometimes you'll have to go down a shaft head first. This is helpful when the patient is trapped in a very small place and there's no room for you to position yourself beside the patient. If the patient has been engulfed by the contents of the tank, an inverted entry is a good idea. This way, you won't put your weight on the area around the patient. As you approach the patient, check if he's breathing erratically. Patients can appear to be intoxicated when there are low oxygen levels or toxic atmospheres. Don't let the patient injure you as you immobilize him. Survey the area. Look for any immediate hazards. Check the patient's airway, breathing, and pulse. It is usually impossible to perform effective CPR in this type of location. Be prepared to rig the patient for immediate removal to a safe location. When selecting the method to use for packaging the patient for removal, consider the mechanism of injury and the immediate hazards that threaten the patient's chance of survival. If the patient is breathing and the atmosphere is safe, consider the necessity of spinal immobilization. If there is a chance of spinal injury, immobilize his cervical spine before raising him out of the hole. Some devices are specially made for this type of situation and have built-in rescue harnesses. If the atmosphere is not adequate or if the patient's condition doesn't require spinal immobilization, use an independent harness, such as a hasty harness, combined with a chest harness made of nylon webbing. You can use a full body harness for the patient, but it will be very difficult to apply a manufactured 4-point harness to an unconscious or immobilized patient. You can use a rescue basket or full immobilization device designed for confined spaces if the opening is large enough. After the patient is removed from the hole and all rescuers have safely reached the surface, move everyone away from the opening. This will give emergency medical services more room to work. It will also prevent an accidental fall back into the hole. Don't immediately remove your respirator if you've been exposed to a toxic atmosphere or material. If you are part of the rescue team that didn't enter the space, be sure to have your breathing apparatus and protective clothing on when you approach the exposed rescuers or patient. Those inside the hole may need to be decontaminated before they're transported to a medical facility. You should be assisted by a hazardous materials team in these cases. After the patient is transported to a medical facility, it's time to secure the scene. An investigation should be initiated. This is usually done by law enforcement or occupational safety personnel. Check your local laws and ordinances for information. Safely retrieve your equipment. If you have to re-enter the confined space, the precautions and rescue procedures that took place during the rescue still apply. Never leave an open hole unattended. Secure permit-required spaces and put signs to identify the area as a confined space. The company or property owner will probably assist you. Don't restore power or services to the area until the investigation is complete and repairs are made. And don't remove your lockout-tagout devices until the property owner is ready to take control of the space. The final stage of the rescue action plan is to prepare for your next response. Be sure equipment exposed to hazardous materials has been properly decontaminated. After you return to the station, inspect all equipment, properly clean the equipment, and return it to service. After the rescue action plan is complete, it's a good time for a critique. Make sure everyone gets a chance to talk. Team members should feel comfortable making suggestions. It will benefit everyone. In this program, Confined Space Rescue, We've presented the highlights of confined space rescue operations. We defined a confined space and discussed the permit-required confined space for general industry OSHA standard. We presented rescuer safety and operational safety information. And we took you step by step through the rescue action plan as it applies to confined space rescues. Remember, all rescue situations are not alike. What works in one operation might not in the next. It's important to be aware of any new or changing standards as they relate to confined spaces. Be open to new ideas and new ways of doing the job.